Hi, as Christian said, I am Silvia Scozzafava. I am from Italy, and I belong to a startup enterprise called Aichi Obiettivo 20 in Italian, which points to the 20th target of the Aichi targets, which some of you may not know. They are the implementing the targets of the Convention on Biological Diversity, and especially the 20th objective points to the need of creating financial opportunities for biological conservation, basically. So we want to point to that target and say we have a need to channel financial flows towards actions that are positive for biodiversity and positive for the environment. And here we are BlockCO2 project, which we like to call the Italian way to carbon removal. So we would like to hear from anyone who is looking for high quality solution for carbon offsetting, because we know that the climate issues are really getting serious. We are all aware of these. And now in COP27, this is really coming through on the news every day. And for high quality solution for carbon offsetting, we mean something that doesn't need to have huge amount of soil occupation or land use conversion. And that is based on a long-term removal of CO2 from the atmosphere. That can be joining nature-based solutions approach with technological approach. And that can maybe also help us to increase agricultural yields and reducing pollution risks, and maybe supporting the development of disadvantaged communities like rural communities and remote mountain territories. Well, this is what BlockCO2 and Credi-C was born for. We are proposing an innovative PIX-based carbon credit system that facilitates the sharing of value across the supply chain. And the word Credi-C in Italian means believe it. And it is the name that we chose for our carbon credit units. Oops, sorry. So what is PIX? I believe in this audience, most of you know what PIX is, but I will just repeat briefly for those who may see this webinar separately as a registration. So PIX stands for Pyrolysis Carbon Capture and Storage. And it refers to the possibility of using pyrolysis processes to draw carbon down from the atmosphere in a durable way. And PIX is acknowledged by the International Panel for Combat Climate Change as a methodology for carbon removal. So it is an acknowledged methodology, and which has already been applied by other bodies and certifying bodies all around the world. Its basic mechanism is that we all know that wood contains some carbon, which was initially drawn down from the atmosphere. In combustion, this carbon goes back to the atmosphere as CO2, and part of the mineral material stays as ash. In pyrolysis, which is different from combustion, part of the carbon stays locked in the chemical structure of the biochar. It is a charcoal material which is very durable, and it's called biochar. So biochar is not just a way of storing carbon, because it has also a lot of interesting properties. It is an organic resource that can increase soil health, and it can contribute not only to climate change mitigation, but also to climate change adaptation by its properties of, for example, enhancing the water retention capacity of soils. But it has also interesting applications as a composting improver, as an additive to animal farming materials such as litter or feed. It has also innovative building applications as a filler in concrete, plasters, and asphalts, adding to these materials interesting properties while at the same time always storing the carbon it contains. And it has even innovative electrochemical applications, which are particularly interesting in the present situation where there is a lot of need of storing energy for buffering renewable energy sources. So it is really a versatile material that is going to open up a lot of innovations from now on in the coming years. We see biochar as a material that can create a cascade of benefits across the supply chain. As we can see here, we pictured a typical example of a possible biochar supply chain. There is a source of biomass which can come from forestry activities or also agricultural activities that gets pyrolyzed in a reactor. The reactor can produce thermal energy, which are a saving of expenses locally, and electrical energy that can be sold on the grid. And the biochar, the raw biochar coming straight from the pyrolysis plant that can be used as it is or sold again as, for example, a component of building materials. Or it can be passed through into farms, animal farms, where its use allows a saving again of costs because, for example, using it in a litter additive can quench the ammonia emissions from the litter, so making the stable a healthier environment. And if added to the feed, it can also improve the animal growth and animal productivity. Eventually, the biochar exits from the animal farm such as straw and mixed manure from the straw environment, from the stable environment, and it becomes, if composted, a better material than it was before. So we have here that the yellow B hexagon symbolizes the biochar improved with the enrichment of nutrients that the passage in animal farming gave it. And if used in agriculture, again, it gives a saving on fertilizers, on synthetic fertilizer, and it gives to the farmer, to the final farmer, a lot of advantages in terms of improved agricultural yield, of reduction of risks, hydrogeological risks and risks from drought and from water scarcity, and eventually the income from carbon credits that can be generated from the whole processes. So eventually we have a whole set of advantages that are one linked to the other, and a whole community can benefit from this modeling of biochar as a cascading set of benefits, and allowing and facilitating the onset of network contracts between the actors and the stakeholders of the rural territories all around. All of these while combating climate change, which is the main driver of this process. We see also biochar as a wonderful tool for ecosystem restoration. We all know how important it is to restore ecosystem to their full functionality, also for their climate effects. The properties of biochar makes it the ideal partner of any reforestation or ecosystem restoration project, because it increases water retention and facilitates microbial growth and the mycorrhizae development. And therefore, it can also be used in soil remediation as it has the capacity of buffering metals and other toxic compounds in soils. So this whole set of properties makes it the ideal partner of ecosystem restoration projects, thus enabling to couple the carbon credits coming from the biochar itself to the carbon credits coming from classical nature-based solutions. And here I come to our BlockCO2 project. What is BlockCO2? It is a whole set of services that are meant to facilitate these whole processes. It is, first of all, a blockchain platform where all steps of the production and utilization of biochar are tracked and can be visible to the final credit buyer, so allowing a high transparency of the whole procedure. It is a carbon accounting methodology that is in line with the existing carbon accounting methodology based on biochar, where all non-renewable energy inputs are discounted from the final carbon accounting, of course, and all the emissions that are avoided thanks to the production or use of the biochar are added to the final credit computation. So also the credit deriving from the applications of biochar are taken into account and calculated. It is, of course, a certification scheme because we set specific procedures and requirements where the pyrolysis plant managers have to abide to and are subject to inspection visits that ensure that the procedures are carried out in the correct way. And last but not least, it is also a biochar marketplace. In a separate section of the website, the pyrolysis plant who need to find buyers for the biochar can showcase their material with all the properties and the specific uses that they are advised for, so that we can facilitate the matching of biochar demand and offer to foster the onset of new credits supply chains and the spreading of these fruitful cooperation networks around the biochar carbon credits. Briefly, we can illustrate how it works. First of all, there is a pyrolysis plant with a supply chain that is working to generate the credits. So we evaluate their actions and their management procedures to evaluate all the carbon removals and avoided greenhouse gas emissions. So including the recovery of energy and discounting all the transport fossil fuel usage or non-renewable energy sources that are used in the process. At the same time, we take into account all the biochar applications in animal farming, in co-composting, green buildings, and agriculture, certifying any certifiable saving of greenhouse gas emission as another kind of credits. We assess the compliance with our standards and procedures that are specified in our management handbook. And through the platform, and here comes the platform role. In the platform, the blockchain technology ensures that all these steps are stored and registered, tracked, and are transparently available to the final credit buyer. At the same time, in the biochar marketplace, there is an encounter between demand and offer of biochar, so that any business can see the business opportunity of this kind of supply chain and decide to invest in these activities. Then the way in which our platform is structured allows a strong storytelling about each credits. So each one of our credits can tell a whole story of sustainability and trustability that can add to the general sustainability strategy of a corporation or of a buyer, because it's not just buying tons equivalent of CO2, but it's buying the efforts and the community history of a whole project, of a whole setting of project, and all the environmental advantages that are linked to this way of operating can be showcased and valorized. As each step is tracked on our blockchain strategy, each actor of the supply chain can be credited for the action they did, so that their role in the generation of value is made evident, and it facilitates the return of value to those who contributed to generate it. So as a resume, a summary, we couple and put together many green approaches to in our blockchain, in our BlockCO2 supply chains. The concept of recycling, recovering waste materials, the concept of producing carbon negative electric energy and heat, the strengthening of the soil fertility, which is also a very pressing topic in the wake of climate change. The reduction of the most powerful greenhouse gases, not only CO2, but the possibility of quenching methane and nitrous oxide with specific applications of biochar, and the whole traceability of the process make our system unique, because we really we expand the concept of carbon credit to include circular economy principles and also nature-based solutions approaches. Something that we are particularly keen on is the possibility of returning the value to all those who created. So we ask the pyrolysis plant to ensure the sustainability of biomass sourcing, and therefore, if a pyrolysis plant is sourcing biomass which has specific features of sustainability, this can be showcased as additional criteria of sustainability that determine an increased value of the final price of the carbon credit that is generated. And the resulting added value that can be credited for the specific sustainability criteria can be returned to the community, giving a premium to those who work for higher environmental standards. In this way, our proposal is more a joining together of carbon offsetting and impact investing, with the possibility of pre-purchasing the credits of developing projects. An enterprise, a corporation, can really invest in the sustainable development of communities in rural areas, in Italy as a start, and anywhere else in the world when we will be able to grow. Our carbon credits can really support local communities and protected areas in many ways. For example, giving additional economic values to operations like forest fire prevention operations that would not be sustainable economically, that would be a burden to the managing body. In this way, the biomass that's recovered by these operations and also other, for example, regenerative agricultural practices can be put to better value and sustain the projects themselves. From the point of view of the customer, we are able to offer our customers a whole set of services that will facilitate the onset of this kind of project, from the first stages of consultancy to set up the biomass flow, so the sustainable sourcing of the biomass, through to the choice of the correct technology that's most appropriate for the kind of biomass that the project is dealing with. Consultancy about the uses of biochar in processes such as co-composting, the agronomic consultancy on its farmland application, and finally, our core service that is the blockchain platform and marketplace for the sale of our credits. So where we are at the moment and what are our next steps? We are a startup and enterprise, so we are moving the first steps in this world. We have the blockchain platform fully functioning in a beta version because we would like to test it with the first projects that will join our vision, our project. And soon after the exit from the beta version of the platform, we will have a consolidated methodology and pricing, and everything will be settled, and we will be ready to take on board any kind of projects beyond the pioneer ones that we are recruiting in these days. We foresee very quickly international developments because we have seen a lot of interest from countries outside Italy. We will facilitate not only the purchase of credits that are actually produced, but also the pre-purchase of developing projects. And the last step we will foresee will be the full automation of credit sales that will allow and make it easy to sell credits in a more direct way. Just a few words about eligible projects. Of course, we ask projects to abide to certain requirements. Very quickly, the pyrolysis plants, of course, must be technological plants, and we do not allow very basic systems such as what I'm calling here backyard beans, so the classic burning with the lack of oxygen in very basic settings. So we ask the plants to be complying with the local regulations on emissions and of handling of any material, and abiding to any regulations regarding energy production as well. We require them to do any form of energy recovery. So at least the thermal energy must be recovered, and it's okay if the plant is recovering also electrical energy. We admit fuel, especially the woody and cellulosic residues that come from forestry and agriculture. At the moment, we do not allow the handling of manure, but we will be open to further evolution in this sector as we gather more evidence. The important thing, in fact, is that the sourcing of the material is fully transparent. So we do not allow any urban waste or other kind of sludges that have an uncertain origin. When it comes to farms, we believe that these projects could be set up also by farms that maybe are running orchards or groves or other permanent crops that produce yearly residues like prunings, trimmings, and thinnings. Also, forest farms could profit from this kind of project, and as well permaculture project that sometimes produce a lot of biomass that may need to be handled in a different way than the ordinary. Rural communities also could be profiting of this kind of tool. Those especially that have residual biomass from maybe the public green management with local pyrolysis plant and biochar applications that can be in local farms as final soil destination. And as a last point, also, as I said, ecosystem restoration projects could benefit from biochar applications like using biochar even as a substitute for peat in a tree nursery, or dealing with the residues that come from the thinnings of initial teak plantations. So this is us. We are based in L'Aquila in central Italy, in the Apennines, in the mountain area. You can follow us on social media and come and see our website. We are developing all these means, so you won't find a lot of material on the website and on social media right now, but we must say that we are improving and increasing the uploaded material all the time. So I'm ready to answer your question as you want.
Thank you very much, Silvia. Very nice presentation, and perfectly on time. So thanks for that as well. So I have a first question. So you talked about the local networks, and I'm really interested. How will you ensure, or how do you try to focus on local networks? Do you have some kind of distance you want to not go over, or what? How is the local included in your platform?
Okay, that's a good question. Very good question. We have estimated that the emission linked to transportation of materials, so whether it is biomass to the pyrolysis plant or biochar from the pyrolysis plant, all these emissions coming from transport are discounted in the carbon credits. But we have calculated that within 100 kilometers, they stay very little, and so they do not impact a lot on the final computation of CO2. So we can consider local as being anything within 100 kilometers of distance. Of course, it is possible also to go beyond the distance. For example, for specific providers or specific materials or customers. In that case, those emissions will be calculated in a specific way. So we need that the pyrolysis plant keeps a registry of the providers and the customers and their locations, so that we can calculate specific emissions linked to transportation phase for those who are not exactly local or always local. At least in Italy, at the moment, some plants do not have everything in a local context, and because the sector is really at the beginning, and so sometimes there are connections that travel a bit too many kilometers. But we will look forward for when the technologies will be more widespread, and it will be possible to not to have neither biomass nor biochar traveling long distances.
Thanks. Thanks for the answer. So you got a question from John Hoffmeyer, who was asking, I think, about the baseline for your biomass. So usually you calculate something against an alternative, or are you doing that? Or how do you compare the carbon intensity of biochar production to that of alternative processing of biomass?
Right. As we are targeting especially forestry residues and agricultural residues, these are materials that are destined to be either burned locally, because sometimes even if the ordinary regulation would forbid to, for example, burn the trimmings and the prunings of trees on the field, in many cases, as there are no viable alternatives for farmers, the local governments give the the permit to burn them on the field. So currently, when it is harvesting season or pruning season, you can see in the fields many farmers burning residues on the field. So their fate would be that of being burnt, or in the more evolved farms, they are incorporated into the soil, and so they decompose in a few years' time. So it is a carbon that would get back to the atmosphere very quickly. And by securing it into biochar and recovering the energy of the process, we ensure that this carbon, if this carbon returns back to the atmosphere, its energy content is recovered, and the carbon that is locked in the biochar will stay in the soil for long and produce many more benefits beyond that. So we believe that given the baseline situation of this kind of material, the system is a certain improvement from that.
I honestly didn't know that in Italy also the residues are still burned, but I mean, makes sense. So you had another question of Edmund So. Can you just evaluate or explain your methodology for evaluating the carbon removal a bit?
Yes.
I mean, you don't have to go into details because I'm sure that will take an hour, but
yeah, for sure. Well, basically, we estimate, we ask the pyrolysis plant to keep analysis of their biochar batches, and on the basis of the carbon content and on the basis of the amount of biomass and the provenance, also the biomass if it comes from far away, that's coming through, we calculate the carbon content that's been locked into the biochar and stored permanently into the ground, taking into account whether there has been transportation costs or energy costs, such as the chipping, for example. If there is a thrashing or a chipping stage of the material, of course it is a machinery that generally consumes electrical energy. We use the standard conversion factors to turn all these into equivalents of tons of CO2, and so the final computation gives the final amount of carbon that's been locked away and not returned back into the atmosphere in any way. And an important thing I must say is that our platform keeps a separate account of carbon removal credits and emission avoided credits, because in the presentation I have mentioned the carbon credits deriving from the abatement of emissions in composting or the energy recovery, the pyrolysis plant. These are all credits that refer to avoided emissions, because if I hadn't used the biochar, my composting pile would have emitted a certain amount of methane. That methane is converted into equivalents of CO2, and so an abatement coefficient is applied, and therefore I have a certification that tells me that some emissions have been avoided. And this is substantially different from the carbon removal, because in the carbon removal, I have actually drawn down carbon from the atmosphere into the soil. So by keeping the accounts separate, we can also keep separate values for those carbon credits. And of course, the carbon removal credits have a higher value rather than the avoided emission credits.
Okay. And then I got a question so far. You mentioned that you pre-finance projects that will produce in the future. Mm-hmm. Is that so far only in Italy, or are you accepting also projects outside but still in Europe?
Well, I can say at the moment we are working with Italian partners that are developing or have already running projects, but we are open to move within Europe, I would say, for certain. And as for other countries, it really depends on the perspective. At the moment, we are a startup, as I said, so it's just a basic team. But if we have the possibility, the opportunity to develop the team at an international level, we welcome partnership or opportunities to expand our operations also beyond Europe. We are so keen of seeing this methodology working that we are really open to partner with other subjects to see it expanding.
And two last questions. First one for myself is you mentioned the marketplace for, mm-hmm. and I wasn't sure, is it a marketplace for certificates or for the physical product?
Right. Thank you for the question. This is very important. the core of the product, of course, is the marketplace for the credits. So the credits are sold by us and we keep the registry. So we need to know who is the final purchaser that buys the credits for using them. We do not normally sell to brokers. So to subjects who buy them and store them away and maybe sell to somebody else. We need to know who is the final user. So we can work with brokers, but only if they work to disclose the final user of the credits. And the second question is that we have also a separate section of the platform that is dedicated to showcasing biochar. It works like a marketplace, but at the moment it is not an actual marketplace, so that it has not any means of automating payment of batches of biochar. It is meant to facilitate those who are looking for biochar to know who is selling them, and the vice versa. I mean, because we notice in Italy, by speaking to project developers and speaking to managers of pyrolysis plant, that is sometimes difficult to match the demand and the offer of biochar. So we sometimes speak with farmers who are desperate to look for biochar and don't find any, and managers of pyrolysis plant that have a lot of biochar and do not know how to sell it. So we realized that it was important to provide a place where those who have biochar can showcase it, and those who are looking for biochar can look up for it in a place where it is transparent which kind of material they're getting. So we have both marketplaces.
Great. And so the last question from Shachek. Can you share the calculation for the compost avoided emissions coefficient? Yeah.
Okay. Yes, these are taken from the scientific literature. They are still under development, so we are not fully confident to disclose them just now. I can say that we are working on a European project to set up a specific procedure that's targeted on industrial composting, while we are working right now on a simplified procedure for home composting and farming composting. So simpler settings where composting happens in a less efficient way and is probably much more helped by the addition of biochar. So there will be probably two slightly different methodologies, and currently they are not as yet consolidated, so I wouldn't be able to share them right now. But they will be released in the following months for sure.